Random forest classifier. RF is equal to random forest classifier n underscore estimators 2000. RF model is equal to RF dot fit x comma y. RF model dot score x comma y. 89.47. Same like decision tree we got, huh? We'll get the same score. No change. It's getting same score. But there will be slight differences in PD dot cross tab y comma sparse matrix. Na? The problem is sparsity in the matrix. But there will be change in the confusion matrix. You see here, decision tree to random forest itself, there is a change. From sklearn dot ensemble gradient boosting classifier. GBM is equal to gradient boosting classifier n underscore estimators 4000. GBM model is equal to GBM dot fit x comma y. GBM model dot score x comma y. GBM predict is equal to GBM model dot predict of x. PD dot cross tab y comma GBM predict. Again, there is a change in the confusion matrix. From sklearn dot neighbors. What neighbors we will do? Multinomial, right? Is equal to multinomial NB. NB model is equal to NB dot fit x comma y. NB model dot score x comma y. 80.46. NB predict is equal to NB model dot predict x comma y. Oh, sorry, x only, na y. PD dot cross tab y comma NB predict. So it is not able to predict 0. It's not able to predict 0 because 0 has very less values. Na? From sklearn dot svm, SVC. SVC is equal to SVC. SVC model is equal to SVC dot fit x comma y. SVC model dot score x comma y. SVC predict is equal to SVC model dot predict PD dot cross tab y comma SVC predict. From sklearn dot neighbors, K neighbors classifier. KNN is equal to K neighbors classifier. Oh, we do grid search, right? From sklearn dot model selection import. Okay. So what is the next argument we have to give? KNN is equal to K neighbors classifier. Then what we have to give? Range is equal to, we have converted it into list, right? Yeah. Grid is equal to grid set CV. This is the param, na? Which data we have used that KNN. K range is list, then param grid dict neighbors is equal to K range, grid set CV param, CV is equal to 5. This is a small data set, right? Grid search is equal to grid underscore search dot 72.7 underscore dot best 10th neighbor is the best param. KNN predict is equal to grid search dot predict of x. PD dot cross tab y comma KNN predict. Confusion matrix. This is the grid search thing. All of you got grid search? You can use it for random forest also. You have to give n estimators is equal to list and then you give the values, not range. And then give n estimators is equal to this and then param grid. You have to give square brackets and give trees 200, 300, 400 like that. You can give 100 or you can give thousands, multiples. From sklearn neural network MLP classifier. NN is equal to MLP classifier. Hidden layer sizes is 50, NN model is equal to NN dot fit x comma y. Max iter is equal to 1000. NN model dot score x comma y. 89.37. NN predict is equal to NN model dot predict PD dot cross tab y comma NN predict. What is this? Neural networks. We have not done the neural network calculation, right? Or we have done? We have not done neural network calculation in Excel. So neural network we will before deep learning image processing. After this we will start. That time we'll start with the neural network calculation. So MLP is multi-layer perceptron, which is nothing but a neural network. Neural network, also called scientific name is multi-layer perceptron. So I think this is the highest, right? Neural network is highest, 89.37. Decision tree, 89.43, I think. Yeah, tree based. But this is also close. See, why I'm not doing cross-validation for this is a very small data set, right? We have 14,000 with 100 and all. It's like we have data, but it's all about words. So, and it's a sparse matrix. So the behaviors will be different. So you can use either tree-based models or you can use neural network model. Anything will work. Because if you see yesterday, there are many zeros. No? All right, I've sent you the data set link for Medicare data, government health service, United States government healthcare service data. This is also real-time data, Medicare dataset, download it because the file is 42 MB. Click on I have sent you by email, the link, web link. Click on the link and click on download the CSV file. No date range, just give 2020 thing. Na? The United States Medicare data, this is very interesting data set. No, CSV also will download. Check it. CSV also will download. Along with PDF, CSV will also download. Check the last modified or last added in your data downloads, you should see it. Hey, who is not getting access? Import NFTK. So when you're importing, add low memory is equal to false because it's larger file. So 25 MB is fixed file download size for import size for pandas, but this file is around 45 MB. So add low memory is equal to false along with pd.read. And along with your normal libraries, also download import NLTK. All right, all of you have imported. Check for missing values. Missing values in what variables? Render provider GeoCD, the geo description. Only two variables, no? GeoCD and geo description. So what is this render GeoCD? On the same website, you will see here data description. So here you can see the variable name. GeoCD is geocode. Code of the referring provides state. Provider geo description. State name where the provider is. Place of service. Number of providers. Number of Medicare beneficiaries. Standardized payment. All these are there. State or national, geographical level. Geocode. Just check that variable. What you have. Value counts or something you will have. No? So what should we do with the missing values there? So what do you have? State codes. Huh? In what format they are? Only 15 missing values are there in the GeoDSC code, right? In GeoDSC code, we have only 15 missing values. So this we can fill it up with national, right? That we can fill it up with national. And we'll keep that data as missing only. CD is equal to Medicare dot provider CD dot fill NA Medicare dot description, right? DSC only, right? Is equal to Medicare dot rendering DC dot fill NA. This is missing. The other one is now if I go back and run the info command again, do you see any missing values? No. None of the columns are missing values here. Missing values are done. Dot HPCSE description. Now this is the variable we are of. This is an NLP variable or the description of the treatment that is given. This column, which is the HCPCS description, is the column where the treatment description is given. So this particular variable description is a text column that describes the treatment given to the patient. Now, rest of the variables you can see there are numerical and categorical, like total beneficiaries, total services, how many days the services provided, average submitted charge, average allowed amount, payment amount, standardized amount. These are numericals. Place of service, hospital or office, like that, it is there. Drug indications or not, yes or no, like that we have. Now, this variable DESC is a text variable. And the dependent variable, you can either choose Medicaid standardized amount or Medicaid paid amount. Any of these two can be taken as dependent variable. Payment amount or standardized amount. With this numerical and continuous data, this is a regression model, right? Float 64 is numerical data, right? This comes under regression model. Now, along with these variables, which we already have, we can build the model and you can delete. What people typically do is they'll delete this. People who don't have understanding of natural language processing, generally they do is they eliminate the text column and using other variables, they'll build a regression model. But that is not the right methodology. We have to use NLP, natural language processing, which we have done yesterday. We have to clean this and then we have to create a document term matrix or term document matrix or TF-IDF matrix. Any of those matrices have to be created and those variables need to be added to this. Then you have to build a regression model. So typically people generally delete this description column, but we cannot delete it. In medical, we know, right? The cost depends on the type of treatment done. The cost of treatment depends on type of treatment done. Now, the type of treatment is described in this particular column. So we have to create variables from this particular column and then use them as independent variables along with other independent variables. Then we should build the regression. So we will work on this column first and then we create dependent variables and then we will go into the other aspects of the data. That is why I've asked you to import NLTK because this column has to be cleaned up. All right. So I forgot RE also. Import RE also. Regular expression is also needed. Now, whatever cleaning process we have done yesterday, we will repeat the same cleaning process. We will separate the Medicare TXT is equal to Medicare dot HCPCS description. We are separating the text into a new column so that we don't, if you make any mistake, the other columns also get corrupted because of the problem. So to avoid it, then we will add other columns also to the data frame later. Okay. So for cleaning up the text column, we are separating it into a separate data frame. So if you say Medicare.text.head, you have to convert it into data frame. PD.data_frame, comma, columns is equal to square bracket single quote HCPCS underscore. Now, all of you do what we have done in yesterday's session. You can open that notebook. Yesterday's session also our data was in this format only, right? Sentences are in the same format, right? So we are using the same format so that you can replicate whatever you have done yesterday. The pre-processing. First, we will remove the, I think there is no square bracket digits here, right? So we don't need to do that. Square bracket digits are not there, but we have digits. Numbers are there, right? So we need to remove, footnotes are not there. What we have to do is, and only thing is we have to remove digits and punctuations. 1 mg, 40 mg, see, rather than that, it is more about the procedures we will get. They might be important, but they may not come in that most frequent. So the problem is you want to find the most frequent, then they may not come in most frequent at all. So you can try that also. So yesterday we have done this thing. After cleaning up, we did the word tokenization from sklearn dot feature extraction dot text from NLTK dot word tokenize underscore or Medicare words is equal to word tokenize Medicare text dot HPCS description. You got an error or the error. STR Medicare text dot description. Medicare words, we have split them into, see, lot of special characters, all these things are there. If you do direct word tokenize without cleaning, see, you got digits 26, 268, 145, right? 268, 148. So we have to delete these, all these things before we do cleanup process. That is why we don't do directly HCPCS tokenize directly. Word tokenize, we don't do directly because we have to remove all those things first. Remove one by one. Medicare text is equal to resub, open bracket, single quotes, square bracket, 0 to 9, single brackets, Medicare text, 0 to 9 plus, right? Oh, sorry, replacement we are not given. No, R has to be there. R, okay. Then we have to remove Medicare text is equal to PD dot data frame text, comma, columns is equal to square bracket, HCPCS description, right? STR Medicare text. We will do data frame conversion at the end only. So after this, Medicare text is equal to read dot sub. We will remove special characters and all, no? Punctuations. So what is the thing which you use for punctuations? Okay. Is alnum is help us to do that. Digits are the major problem. What else we have to remove? I don't think anything else is there, right? Top bits we'll do later after converting into words. Or we can do in tokenizer also, right? It got completely corrupted. So we'll do a slightly different version. Medicare text is equal to W for W. We'll run word tokenize and then we'll clean it. Medicare words is equal to word tokenized Medicare text. Why we got another again? STR Medicare. Okay, we got the words like this, Medicare words. Medicare words is equal to square bracket W for W in Medicare words W dot is all num. But still we have digits. Remove digits, Python. Medicare words is equal to square bracket W for W in Medicare words. If not, we have removed this. Now we have this first, second also. How do we remove them? Break it. So remove digit from list in Python. Alphanumeric, right? Alpha. So resub. Remove alphanumeric. Okay, regex. These are the things. Yeah, I think we'll use this. Sending it by email. It's a large thing. W for W in Medicare words. If not, oh, we deleted the complete list. Okay, we'll select words greater than 3. Medicare words is equal to square bracket W for W in Medicare length of W greater than 3. Yeah, now I think most of it is gone. But we got very less words. We got only 35 words. Right? So use this function where I have earlier created to do all the cleaning. So run the function, copy paste the function, run the function. Then we convert it into a data frame. Then we convert it into lower. Email it. From here onwards, you have to do it. So you check the word cloud for anything which is not relevant. You see anything which is not relevant, like special characters. Anything problematic in word cloud? SARS-CoV, SS, ND is there, MG is there, ST. Let us see what is the size of the corpus. All of you have done till word cloud. Medicare words is equal to Medicare words. Okay, length of Medicare words. What is we got? Underscore words 268. Okay, we are getting all rows twice. Medicare underscore words is equal to Medicare underscore words dot map dot join. We are combining everything into one single list. Ln of Medicare underscore words. Hey, we are not in the frequency distribution, right? Okay, no problem. From sklearn dot feature extraction dot text count vectorizer. Yesterday we have used TF-IDF vectorizer. Today we will use count vectorizer. Is equal to count vectorizer stop words is equal to stop words comma max underscore features is equal to NLP underscore DTM is equal to DTM dot fit underscore transform Medicare underscore words. Oh shit, you got an error. Empty vocabulary. NLP underscore DTM dot shape. Yeah, 268, 149, 300 columns. PD dot NLP DTM to array, comma, columns is equal to DTM dot vocabulary underscore. Okay, stop words are there here. Yesterday, how did we remove stop words? We removed before that only, right? So we are getting stop words, so we have to remove stop words. Medicare for words, we have done it in the earlier in the top only, right? We'll also take words greater than. Why we are getting greater than 3 also? No, but what about the this one? Words. I see 2-letter words still. See, in is there, on is there. You got all proper words. Then where is my problem coming in? So yeah, see, I also do that thing where I did this stop words without using these 2 steps. But where did you use the stop words? So you have used this one, this one, huh? Both. Okay. Stop words is equal to, right? You have used this one, right? Dot map join. But ML and MG we have to remove. ML and MG, we have to remove. In NLP, he is asking to remove beforehand only. If we give n-gram range, this looks better, right? I think give n-gram range is 2. This will solve us the problem. Anesthesia procedure using endoscope, soft tissue, gene analysis, ray imaging, blood vessel, brain, spinal cord, needle biopsy, blood vessels. So we got good set of words here. We'll use bigrams. All right, done. This is our data frame, NLP DTM. We'll convert it into data frame. NLP underscore DF is equal to convert it into data frame. Remove dot head, otherwise it will take only 5 lines. Add the name and remove dot head. NLP DF. Let us look at our other variables. These are our other variables, other non-independent other variables. Num calls is equal to Medicare dot select underscore D types include is equal to NP dot object calls is equal to Medicare dot select underscore D types include is equal to square bracket. So num calls dot columns object calls dot columns. Okay, we have split the other variables. Other than we have created NLP as a data frame. We'll concat them, right, with other 2 variables, but we have to do pre-processing, right, on num calls and as well as object calls. All of you completed the NLP DF. So NLP data frame is the data frame which is with 300 variables. And we are not bothered about the variable count because we have 2 lakh rows of data. Only thing is random forest and gradient boosting will take a lot of time to run. Rest of all will run faster only. All of you split the data, num calls and object calls. Num calls dot head. So we have data in very different numbers. So what should we do first here? Multicollinearity. How do you check multicollinearity? SNS dot heat map num calls dot CORR comma not is equal to true. I think we have to increase the figure size. No, I think it should be enough. We'll increase the size. PLT dot figure is equal to 20 comma 10. Now it is clear, right? So we have multicollinearity. Oh, we have multicollinearity. All the allowed amount, payment amount, and standardized amounts. So we have to remove payment amount and allowed amount. Or we will remove allowed amount and standardized amount, keep payment amount. You can choose any one variable. See, clear multicollinearity, right? So what we will drop? We will drop Medicaid standardized amount. We will take payment amount as our dependent variable. Num calls is equal to num calls dot drop. Why we are dropping them? Because of multicollinearity. Average Medicare allowed amount, average Medicare standardized amount, comma axis is equal to 1. Now we will check for multicollinearity again, right? No multicollinearity, right? So we will drop these 2 columns based on multicollinearity. Now object calls for call in object calls or for I in, because some people are getting confused. Object calls dot columns object calls frequency is equal to object calls square bracket I dot value underscore counts drop NA is equal to false. We are printing the frequency of all the object calls in one go. So for the first variable geo level, there are 2 categories, state and geo level has 2 categories, state and national. Then we have imputed missing in the variable then we imputed national in what you call geo description. Then HCPS code we will delete it. It's numerical code, HCPCS code, and HCPCS DAC. We have already done that. We have to remove that also. Drug indication, place of service. We'll keep. So we will delete HCPCS code and HCPCS description, right? And we'll also delete that GeoCD because we have state names. This state codes we will remove. Geo code because we already have state names. Geo description is there, right? So we'll remove these columns. Object calls is equal to object calls dot drop HCPCS code and HCPC description. Rendering provider GeoCD because we have state names, right? Is equal to 1. Object calls dot head geo level geo description drug indication. Shall we remove geo level also? Because here you have national and state geo level. Here you got state names, national and state names. So let us see. It causes multicollinearity in logistics, then we'll delete it. Object calls underscore dummy is equal to PD dot get underscore dummies object calls dummy dot 68 columns it has created. Only thing is that state names are there, na? In US, you have 50 states. So 50 states and then the other two. National is also there. Military is there. Unknown is also there, I think. Medicare underscore DF is equal to PD dot concat NLP underscore DF object calls dummy, comma, num calls, comma, axis is equal to 1. Concatening the NLP variables, object called dummy variables, and we have not scaled the num calls, right? Yeah. From sklearn dot pre-processing import standard scalar, we have a lot of outliers. SNS dot num calls, comma, orient is equal to H. So we have extreme outliers. So we'll use robust scalar. sklearn dot pre-processing is equal to, we have to draw, we can't do Medicare payment scaling. That has to be do transformation, right? So how do we, okay, no problem. Num calls underscore is equal to, comma, axis is equal to 1 dot apply fit underscore transform. Fit underscore transform num calls dot drop num calls underscore robust is equal to num calls underscore, sorry, pd dot data frame. pd dot data frame num calls robust, comma, columns is equal to, what is the column names? There is that num calls. So we have scaled to check how it has worked. Num calls underscore robust, orient is H. Hey, not much of a difference here. Robust, you can't see any change, right? Did you guys get it? But there is not much of a difference. Maybe individually we have to check. నేను అప్లై చేశాను కదా మీకు రెండు తెలుసు అది అవుతుందా లేదా ఎందుకంటే ఎవరు ఏం మాట్లాడట్లేదు ఓకే well, if you got this, y is equal to num calls average Medicare payment amount, x is equal to Medicare underscore DF. See if y has create the box plot, 10 sticker and histogram of y in one single plot. So pick comma ax, right? SNS dot y comma ax is equal to ax square bracket 0. SNS dot box plot orient is equal to h, comma ax is equal to ax square bracket 1. SNS dot kd plot y comma ax is equal to ax square bracket 2. Extreme positive skewness is there, right? You can see there is an extreme positive for the dependent variable Medicare payment amount. So what should we do? What transformation we will do? Do it logarithmic transformation. Reception में दे दो, third floor reception में दे दो. SMS చేసిన చూడండి. Okay, so what transformation you should do? Logarithmic transformation, right? np dot log of y, np dot log of np dot log of, yes, to some extent it is coming to not as bad as the previous one. This is a little bit better, right? Logarithmic transformation. So we'll use logarithmic transformation of y as our dependent variable. So build multiple linear regression model. Build multiple linear regression model from sklearn dot linear model import linear regression. Reg is equal to linear regression. Reg model reg dot fit x comma np dot log of reg model dot score x comma np dot log of y. 56.21. Reg predict is equal to reg model dot predict. Reg predict is equal to np dot exp of reg predict. Converting it to normal. Resid is equal to y minus reg predict. np dot sqrt, np dot mean, reg resid, very large RMSE we got, right? Extremely high we got. Why we got like this? Already very high difference is there, right? So very worst RMSE we got. All right. From sklearn dot tree, decision tree regressor. Tree is equal to decision tree regressor. Tree model is equal to tree dot fit x comma y. So why I am not using logarithmic transformation? Because this is a non-parametric algorithm. Decision tree is non-parametric. So even if it is skewed, we can still use it. Whereas regression is a parametric 99.99. So 7981, not that bad. NP dot mean 99 and 80, 91 and 84. So decision tree with depth of 10. Okay, we are getting good model. Accuracy is 91 and cross validation 84.5. Less than 10% up and downs. Tree predict is equal to tree model dot predict tree reset is equal to y minus tree predict. NP dot sqrt, NP dot mean tree reset very low RMSE. See, so we build the tree with 10 depth, cross validated and calculated the predict, and we got the RMSE 184, which is a very low RMSE, right? Hey, when will you give mock interviews? No, third week will be last week of your curriculum, most probably. My sessions will be over by end of this month. The Hadoop and other things are there, Power BI and all, those sessions will go on for another 1 month, and also placement simultaneously will start. So typically you will start getting emails, subject that you have already created your GitHub profiles with regression and classification models, and send it to Saicharan with resume with your GitHub link. They will start pushing you the jobs from 20th of this month. So that's what I told him. By 20th, to send your resume to him with your GitHub profile, LinkedIn profile, and your resume should have 3 projects, GitHub projects. Like I sent you the template, right? So those 3 GitHub projects should be there and everything ready. You will start getting the opportunities from 20th onwards. So mock interviews we'll give on Monday. If you are prepared, you can give on Saturday also, because they will be recorded. Even if they are happening in the class, you will be sitting in one of the cabin and you will be giving the interview on Zoom, which will be recorded. Because if I do it in the last week, if there is some problem, we will not have time to correct. If I do it next week, we'll have 2 weeks time to correct. Feedback on improvement areas, face the interviews, and interviews will have first introduce yourself, then exploratory data analysis, hypothesis testing, machine learning regression, machine learning classification, and then other aspects of machine learning, dimensionality reduction, unsupervised learning, K-means clusters, all those things. So what I would suggest you is you read the PDF files which I have sent you. They have the notes, right? EDA, everything you should need to know. In case of regression and classification, you should have basic idea of MLR and binary logistic regression. On the remaining algorithms, you choose any 1 or 2, or choose any one algorithm which you are comfortable with reading. Okay. And in unsupervised learning, you choose between dimensional reduction and K-means clustering. You're getting the point, right? So models, you don't need to prepare all. You have to prepare multiple linear regression and binary logistic regression full with assumptions, everything. And then choose one of your favorite other algorithm which you are comfortable with. Decision tree, random forest, gradient boosting, KNN. We have studied other name bias, whichever you are comfortable with. That you study thoroughly, complete. Similarly, unsupervised, choose either principal component analysis or K-means clustering. Complete algorithm you need to study, right? And I forgot, sorry, data pre-processing, missing value imputation, compulsory. Missing value imputation, right? Difference between dummies and label encoder, these things you have to, and whoever is comfortable, they can start giving either on this Saturday, Sunday, you can give me a call, we'll schedule a slot and we'll take it. It's good for you only, give beforehand so that we can identify your weaknesses and we still have time to work upon them. That's in your benefit, benefit only. Because if you don't give marks, you can't decide how much level knowledge you have, whether you're industry ready or not. Interviews will be taken just like how the practical real-time interviews will happen. Just now we have discussed this thing, so we have to